Now, the first example, under stationary points in two variables, you'll be told to determine and classify the stationary points of the function f of xy to be equals to 3y cubed minus 2xy plus 5y squared minus 4x squared plus 6. Now, for you to determine the stationary point and classify their nature, the first thing you need to get are those 6 partial derivatives, isn't it? You have to determine those 6 partial derivatives. So the first one you start with, you differentiate partially with respect to x. So when you differentiate this partially with respect to x, that is f subscript x to denote partial derivative, isn't it? Meaning in this case, when you are differentiating partially with respect to x, it means what? Only x is considered as a variable, anything else is a constant. Are you see that? So we are differentiating this partially with respect to x, meaning there is no x in this term. So it means the whole of this term is a constant because we are doing it partially with respect to x, isn't it? So the whole of this term is a constant. And when you are differentiating a constant, you get 0, isn't it? Then you go to the next term here. When you are differentiating partially with respect to x, meaning negative 2y is a constant, isn't it? So when you differentiate x, you get 1, isn't it? So what do you remember there? Negative 2. Because this term here, we have negative 2xy. So it is negative 2y, which is a constant, and we are differentiating partially with respect to x, meaning this x is the variable only. You see? And when you differentiate this x, you get 1. Because differentiating x is raised to power 1. 1 times the constants, 1 times negative 2y, you get negative 2y, then you reduce the power by 1. X raised to power 0, isn't it? Anything raised to power 0 is 1. So it means we just remain with the 2. So negative 2y in that case, isn't it? Then you move to the next term. If you are differentiating 5y squared, see there's no x here. And we are doing it partially with respect to x, isn't it? So when there's no x here, meaning this is a constant, isn't it? So when we are differentiating a constant partially, what do we get? 0. You go to this next term. Only x is a variable, anything else is a constant, isn't it? And there's x here. So you cannot differentiate. So 2 times negative 4, negative 8, then you reduce the power by 1. 2 minus 1, you remain with x raised to power 1, which is just x, isn't it? You are done with that term. If you differentiate a constant, you get 0. Have you seen the way we've done partial differentiation? When we are doing it partially with respect to x, only x is a variable. Anything else is a constant. Is that understood? So it means once we found this partial derivative, the next thing we do, we get those remaining 2. Meaning if the first time we differentiated partially with respect to x, we can now do it for the second time with respect to x again. Are you seeing that? When we do it for the second time with respect to x, meaning if we differentiate negative 2y, see there's no x here. Meaning that is a constant. So if you are differentiating a constant, what do you get? 0. So you are done with that. Then you move here, when you are differentiating negative 8x with respect to x, you see we are doing it for the second time with respect to x. So this x is a variable, isn't it? And this our x is a silent one. So negative 1 times negative 8, you get negative 8, then you reduce the power by 1, x raised to power 0. Anything raised to power 0 is 1. So you remain with negative 8. Are we together? We are done. Then you come back again. The first time, you did it partially with respect to x. So instead of doing it for the second time with respect to x, we now want to do it for the second time with respect to y. Are you seeing that? Are we together? So the first time we've done it with respect to x, the second time we now want to do it with respect to y. Is that okay? So with respect to y, you go here. Negative 2y, meaning only y. When we're doing it with respect to y, meaning only y is a variable. Are you getting the concept of partial differentiation? Now only y is a variable because we are now doing it with respect to y, but not x. Is that okay? So when you differentiate this, it means y is raised to power 1. So what do we have? 1 times negative 2. Then you reduce the power of y by 1, you get y raised to power 0, isn't it? Anything raised to power 0 is? So you remain with negative 2. Then you go here to 8x raised to power 1. See, that is a constant. Because we are dealing with respect to y, meaning only y is the variable, anything else is now a constant. Is that okay? So we've now found the 3 partial derivatives. So it means we are done when we started this. So now we see what if we did it for the first time partially with respect to y, isn't it? So what if we did it, we differentiated it partially with respect to y subscript y. Now instead of x, we now want to differentiate this function partially with respect to but not x now, isn't it? Are we together? Yes. Now when you're dealing with partial with respect to y, what do you get? Only y is available in this function, isn't it? So here, what do you get? 3 times 3? Then you reduce the power of y by 1, isn't it? You get that? Then here, only y is available, meaning this negative 2x is a constant, isn't it? Only y is available when it is partial differentiation. So if you differentiate y raised to power 1, what do you get? So you get 1. Because y is raised to power 1. So it is this, if you have negative 2xy, this negative 2x is a constant because we are doing it with respect to y. So here 1 times this constant, you get negative 2x, then you reduce the power by 1, y raised to power 0. Anything raised to power 0 is? So it means we are going to remain with the negative 2. Are we together? We are done with that. To move to the next one. Only y is a variable. So if you differentiate this, there is y, isn't it? So you have 2 times 5. So it is plus 10 y, because you reduce the power of y by 1 when you differentiate it, isn't it? Then here there is no y here, and only y is a variable, so it means the whole of this is constant, isn't it? When you differentiate a constant, you get 0. Here is a constant. When you differentiate a constant, you get 0. So have you seen, we've now dealt with it with respect to y. Are we together? Now after dealing with it with respect to y, meaning we can now get those two more, isn't it? So in this case, it means the first time we differentiated with respect to y, the second time we now want to do it with respect to y again. So y we get the y squared, isn't it? The first time here we've done it with respect to y, meaning if we differentiate this again with respect to y, it is now for the second time. Meaning we are from here to get this, then we are from here to get that, isn't it? Are we together? So, if you differentiate this again with respect to y, where there is y, only y is available, partially. Okay? So, what do you get here? 2 times 9? 18y. You reduce the power of y by 1, isn't it? Then if you differentiate this negative 2x, there is no y here. It is a constant, because we are doing it with respect to y, meaning the whole of this is a constant, isn't it? When you differentiate a constant, you get 0. Are we together? Then you move here, there's y here. If you differentiate this, what do you get? Plus 10, because y is raised to power 1, isn't it? So 1 times 10, you reduce the power of y by 1, y raised to power 0. Anything raised to power 0 is 1. We just remain with 10. Are we together? So that means when we did it for the second time with respect to y, remember here for the first time, we did it with respect to y. Now for the second time, instead of doing it again with respect to y, we now want to do it with respect to. So you don't even need to do it. It will be the same as that, because we found this is the same as that. You will get negative 2, because this is always the same. If you start with x followed by y, or if you start with y followed by x, you find it will be the same. Are you seeing that? So it means when we are doing it for the second time partially with respect to x, now it means y is a constant, isn't it? So it means this term 9y squared is a constant. If you differentiate a constant, you get 0, isn't it? Then here, only x is a variable. If you differentiate negative 2x, you get negative 2. Then here, there is no x, meaning the whole of this is a constant. If you differentiate a constant, you get 0. Meaning this is always the same as this. Symmetric, isn't it? Are we together? Now, after you found these 6 partial derivatives, they are now helping you, the first case, it is helping you to get what? The stationary points, isn't it? So here what we found here, the first one we found, if we differentiated it, partial with respect to x, we found minus 2y minus 8x, and this one has given us, if you differentiated that, you got negative 8. If you did that, you got negative 2. Then again, when you differentiated for the first time with respect to y, you got 9y squared minus 2x plus 10y, isn't it? If you did it for the second time, what did you get? 18 plus 10, isn't it? Then f of yx, what have you found? Negative 2. So, having found those, we now want the stationary points. So at the stationary point, what did we say? At the stationary point, the derivative is 0, isn't it? At the stationary point, the derivative is. So it means it is either this derivative which is 0 or this derivative which is So it means at the stationary point, either the derivative partially with respect to x is 0, or the derivative partially with respect to y is 0. Isn't it? You see that? So you come and substitute your partial derivative with partial with respect to x. What did you get? Minus 2y minus 8. Minus 2y minus 8. X to be equals to 0. Or partially with respect to y, what did you get? 9. 9y squared minus 2x plus 10y is equals to. So you can see these two equations are simultaneous equations. So it means when you solve these simultaneous equations, you get the stationary point, isn't it? Are we together? So it means we've determined the stationary point when we solve this equation. Then after that, we classify. When we classify, it means we are stating their nature, isn't it? We have classified it to be a shadow point, we have classified it to be either maximum or a minimum, isn't it? Are we together? So can we solve this equation? So you look at the equation and you check the method which is similar and which one to do with. If I say here, this equation, one is linear, one is not linear, isn't it? So it is easier to use substitution, isn't it? Because if you look at this first equation, so you can write y to be the subject of the formula very easily, isn't it? The first equation, you have minus 2y minus 8x equals to 0. It implies that minus 2y is equals to negative x. 8x going on the other side, you get 8x, isn't it? So for you to get y, you divide both sides by negative 2. Are we together? You divide both sides by negative 2. So that implies that y is negative 4. 8 divided by negative 2, you get negative 4x, isn't it? Are we together? So there it means when we are using substitution in the second equation, meaning where there is y in the second equation, anywhere you see y, what do you put? Negative 4x, because we are using substitution. Are we together? Anywhere you see y, you put negative 4x. So in the second equation, we have 9y squared. 9 into y squared, because y is the same as negative 4x. So it means anywhere we see y, we put negative 4. Is that understood? Yes. Then it is minus 2x plus 10y. Anywhere we see y, we put negative 4. So it is 10 into y. But y is negative 4x from the first equation, isn't it? So this one is equals to. So it means through substitution, we are able to eliminate y through substitution, isn't it? Is that okay? So can we now simplify? Negative squared is positive, isn't it? 4 squared is 16, isn't it? Are we together? I have 16 times 9. Calculator. 16 times 9. 140. 144. Then x is squared. 144x squared, isn't it? Then here we have 10 times negative 4. See negative 40x. So here we have negative 40x and here we have negative 2x. We have a total of negative. So this is negative 2x. And this is negative 40x. So negative 2x and negative 40x gives you a total of what? Negative 42x to be equals to 0. So are you seeing this is a quadratic equation? Isn't it? So in this quadratic equation, what do you see? It is x into 144. You can see 2 is a common factor. Get rid of that 2. Not even a 2. It is a very, because 3 is also here, 6 is a common factor, isn't it? So if you divide all 2 by 6, what do you get? Because we want the simplest form, senior. If you divide all 2 by 6, what do you have? 24. So you have 24x minus 7x is equals to, so if you divide all 2 by the common factor, isn't it? We get 24x squared minus 7x equals to 0. So what do you have here? X into 24x minus 7 is equals to 0, because x is a common factor. We factorize a common factor outside, isn't it? So in quadratic, you know very well, if a product of 2 factors is 0, then it is either the first factor which is 0 or the second factor which is, when you have a product of 2 factors to be 0, isn't it? It is either the first factor which is 0 or the second factor which is 0. That is why you are getting a 0, isn't it? So this implies that it is either x is equals to 0 or 24x minus 24x minus 7, which is 0, isn't it? So what do we get to be the values of x? X is equals to 0 or x is equals to 7 over, because negative 7 going on the other side of the equation, it becomes positive 7, isn't it? Then you divide both sides by 24, isn't it? So that you get x is either 0 or x is 7 over 24. Are we together? And these values of x you found. You found these values of x when y is what? When y is negative 4. So start with this. When x is 0, what is y? When x is 0, y is negative 4x, meaning negative 4 times 0. Are you seeing that? Because the first equation we found y to be negative 4x. But when x is 0, what will be y? So it means where there is x input 0. So when x is 0, y will also be 0. So this one now gives us the first point in the form of xy, meaning the first point is 0, because points is the form x comma y, isn't it? Are we together? You move to the next one. When x is 7 over 24, what is y? Y is negative 4x, meaning it is negative 4 times the value of x, isn't it? Because these two coordinates, they are coordinates, meaning if you have one, you get the other with the equation relating them, isn't it? So when x is 7 over 24, what is y? Negative 4 times 7 over 24. What is the value of y? Negative 7 over 6, isn't it? Have we done it with the calculator? And you know, this is not the calculator we are using for this one, but we talked about that, and we will not repeat ourselves. What have we found? Negative 7 over 6. So what is that point? It is in the form x, comma y. So we found the two stationary points. The first stationary point we found is 0, 0, and the next stationary point we found is 7 over 27, comma, negative 7 over 6. So we've determined the stationary points. Are we together? We've determined the stationary point. So after this determining the stationary point, we now want to classify them, isn't it? Meaning when we are classifying the stationary point, what are we doing? We are stating their nature, isn't it? So for us to state their nature, we have to look for the determinant of the Hessian matrix, isn't it? The determinant of that Hessian matrix. Let us now state the nature of these two stationary points we found. Are we together? Let's state the nature. So, you know that f is a function of x and y. So it means when you are constructing the determinant of Hessian matrix, when you are constructing two variables, it means it is a 2 by 2 matrix, isn't it? It's a 2 by 2 matrix. So your f is 2 by 2, f. So you define row first. Is when you define a column after you've done with the rows. Order of a matrix, okay? So x is the first member here, meaning x forms the first row. So you will define the first row. You are done with the first row. Are we together? Then you define y is the second member, y forms the second row. The horizontal arrangement, isn't it? Then y second row. So you define row 1 is x, row 2 is y. That order. You must follow the order. X must come first, then followed by y. We are done with the row. You now move to the column, you define column second, and when you are defining column, that order must follow. Are we together? So when we are defining column, x comes first, meaning x is first column, isn't it? So the column is that. So this first column is x, meaning it is x. Are we together? Then y is second, y forms the second column. So second column is y. Are you seeing how to construct a Hessian matrix? So, what is the determinant of this Hessian matrix? Now, for you to get to substitute the values of this, you substitute with the points. Are we together? So, once you've written this formula, you start with the first stationary point. We want to classify this stationary point 0, 0. Meaning, this stationary point 0, 0, what is the determinant of the Hessian matrix? You go to f of x. Go. Where is your f of x? Negative 8. Are we together? Meaning that you don't substitute anything, it is already a constant, isn't it? So if you substitute that, you get negative 8. The next one is f of xy. You go back. Where is your f of xy? Negative 2. You come and you record your negative 2 there, isn't it? Are we together? Then you move to your f of yx. Your f of yx is negative 2. You substitute it there. What is total? All these are constant. You put direct, isn't it? Then the next is f of yy. What is f of yy? 18y plus 10. What is 18y plus 10? Meaning you get rid of this y. And what is the y value of this point? Y value of this point is 0, isn't it? So it means when you put 0 here, what do you remain with f of yy for this point? 10. Meaning it is 18 times 0 is 0 plus 10. Meaning f of yy at this point is 10. Meaning each and every point has its own values of this second order partial derivative if they are not a constant, isn't it? Are we together? So what is this determinant? Go to the calculator, the product of the elements in the main diagonal minus the product of the elements in the minor diagonal. Use the calculator to get the product of the elements in the main diagonal, negative 8 times 10, minus the product of the elements in the other diagonal. What do you have? Negative? This is negative 80 minus 4. That is negative 84. So you found it is negative 80. So what does that imply? If you found the determinant of the Hessian matrix to be negative 84, it means the determinant of the Hessian matrix is less than, what did we say? We said when the determinant of the Hessian matrix is greater than 0, it is a turning. Remember, it is the discriminant. When the discriminant is less than 0 is when you get a turning point. But for the Hessian matrix, when it is less than 0, it is a shadow. Are we together? Are you seeing the difference? So it means when the determinant of the Hessian matrix is less than 0, then it implies this our stationary point is a shadow point. You know very well that when the determinant of a Hessian matrix is less than 0, then that implies that the discriminant is greater than 0. One is opposite of the other. Are we together? Are we together? Yes. So when the discriminant is greater than 0, it is the shadow point. You see the difference? Okay? Good. So we've classified the point 0, 0. We go again and we classify the next point, isn't it? Can we now classify the next point? Come and put the point. The point is 7 over 24, comma negative 7 over 6. Can we now classify this? Get the determinant of the Hessian matrix. What do you have? Start. F of xx. What is f of xx? Negative? Negative 8. Remember, when it is a saddle point, you don't look for the second principal minimum, because the second principal minimum only define the maximum or minimum point if it was a turning point, isn't it? Are we together? Good. Then move to the next one, f of xy. What did you get? Negative 2. Then the next one, f of yx. Negative 2. Then the next one, f of yy. 18y plus 10. But what is y for this point? Y point for this point is negative 7 over 6, isn't it? So it means you substitute y value for this point, isn't it? So negative 7 over 6 times 18, negative 21, isn't it? Negative 21 plus 10, what have you found in the calculator? The calculator is giving you negative 11. You have to use calculator all the time. My friend, what we are going to do in this mathematics, those calculators are not going to work out. You are going to see. We've talked about this over and over again. These calculators are going to drag you behind. Okay? Are we together? Can you look for the right calculator? So, what do you get here to be the determinant? The product of the elements in the main diagonal minus the product of the elements in the other diagonal, negative 8 times negative 11 minus negative 2 times negative 2. 84. Use calculator. What have you found? 84. So that is 84. So when you get 84, it means 84 is greater than, when the determinant of a Hessian matrix is greater than 0, what does it imply? It implies the discriminant is less than, and when the discriminant is less than 0, what does that imply? It implies a turning point. Are we together? Because the discriminant is the negative of the determinant of the Hessian matrix, isn't it? Are we together? So a turning point. So what is the nature of that turning point? The nature of the turning point is defined by the first principal minimum, f of xx, isn't it? So what was your f of xx? What is your f of x? What is it? Negative 8. What is negative 8? Negative 8 is less than. So when the first principal minimum is less than 0, that implies what? It implies that this our point 724, comma, negative 76 is what? It's a maximum point. When the second principal minimum is less than 0, it is a maximum point, because we've already defined the turning point with the discriminant. When it is a turning point is either a maximum point or a minimum point, isn't it? And when the second principal minimum is less than 0, it is a minimum point. Are we together? Very good. So that is how to handle such kind of problem.